Good afternoon, everybody. I'm just going to give it 1 minute and allow the rest of the joiners to sign on, and then we'll get going. Okay, it's 2:01. I'm going to get started over here. So good afternoon, everybody. Thank you so much for taking the time out of your day to hop onto this webinar. I'm going to go over EFOY Pro Hybrid Solutions, and I'm going to tailor this presentation specifically around the oil and gas applications. And I hope you guys can see my screen and hear me.
All good.
Perfect. Okay, so what I'm going to cover, I'm just going to do a very brief introduction on who Simark is, and then I'll do a really high-level overview of how we generate power, how we package power, and then I'm going to get into very application-specific examples. I'm going to cover over 2 different block valve situations, cathodic protection, pipeline risers, and then a SCADA and instrumentation application as well. So we've got about 25, I want to wrap this up in 25 minutes if I can, and leave lots of time for questions. So if you guys don't know me, my name is Chelsea O'Connor. I do business development for Simark, and I focus on the EFOY fuel cell. So at the bottom of your screen, you're going to see a small chat window. If you do have questions, please type in your questions here. I won't be able to see them as we present, so I'll cover over everything at the end. When you send in a question as well, it also tracks it to your name. So if for whatever reason you need to hop off the webinar and I didn't get a chance to answer your question, I will make sure that I follow up with you. So for those of you that aren't familiar with Simark, we've been in the industry for almost 50 years, providing service and support to various industries around the world. For the most part, here at Simark, we are based out of Calgary. That's where we've got our production facility. We recently opened up an office in Grand Prairie. We're out in Vancouver and out east as well. So for the EFOY fuel cell, we do all the packaging and integration local in Calgary, and then we have customer service support 24/7 online, and then we also offer service training and actual boots on the ground too when it's required. So what you might not know is Simark was acquired about 5 or 6 years ago from a company called SFC Energy. And so SFC actually manufacture and develop the fuel cell technology. So we are the distributor, the manufacturer of the technology. And while we get the fuel cell itself from Germany, like I'd mentioned before, we're doing everything here local in Calgary. For the EFOY fuel cell, so what it is it's basically an off-grid power solution. So the way that it's producing power is through a chemical reaction. So we're a direct methanol fuel cell, so you could call us essentially a cold fuel cell, which means that we're able to start and stop on demand. So the way that we're producing power is through energy input is going to be ultra pure methanol running through a platinum catalyst inside the stack of the fuel cell. From there, you're going to get straight DC power. You're also going to get a small amount of water vapor, CO2, and some heat off the unit when we're generating power as well. So the way we've designed this system is we design it to work in conjunction with solar. So really you can think about the fuel cell as a smart battery charger. What we're doing is we have solar array that's all tied into a battery bank, and then the fuel cell has voltage sensing lines that connect to that battery bank and just monitor the state of charge at all times. So when your battery's discharged to, let's say, 50% depth of discharge, the fuel cell's automatically going to turn itself on. It's going to carry your load. It's going to bring your batteries back up to float, and then it's going to sit back in standby mode, and it's going to wait for your batteries to drop again. So you can really think about it as a built-in battery charger. So the graph that you see right here, this just gives you an idea of how we're sizing and designing our systems. If you're familiar with standalone solar, the way that you would size a traditional solar system is you're looking at your highest load and the worst case conditions for that specific region where you're installing, and that's how you size that system. Because you've got the fuel cell built into the package, it's a little bit different. So what we're doing is we're looking for your average power consumption, and then we're pulling the solar for based on the installation point. But we're really sizing solar to work in the summer months when we know that solar energy should be available. And then the EFOY is really just going to backfill the winter months up here in Canada when we know that solar has its challenges. So in this graph, this is your load staying constant. This is solar, and then these green bars right here, that's just showing you what we expect for methanol fuel consumption during operation. So the smallest fuel cell that we offer is 45 watts. The largest is going to be a 500 watt system just for a standalone unit. When we do run into situations where we require higher power, for example, a telecom installation that might need 1 kilowatt, we can parallel units together to meet rated power. So we range from 45 watts to 2.5 kilowatts. The energy input for our system is ultra pure methanol. So the way that we're doing this is we've got fuel cartridges that are integrated into the package. The way that we size it is so that you can get at least 12 months of system autonomy. So that's solar, batteries, and fuel cell all operating at the same time. And from there, the fuel cartridges themselves, they're designed to be safe for air, truck or ATV transportation to site as well. So it's really simple to install. It takes less than 10 minutes to swap out the cartridges. The way the fuel cell is designed is it's going to drain cartridge 1 completely empty. For the most part, in our packages, we're going to give you 2 cartridges. Sometimes you get more depending on how much autonomy we've designed the system for. So the system's going to drain 1 cartridge, and then it's going to switch over to cartridge 2. Because the EFOY's got Modbus communications built directly into the system firmware, depending on how you're monitoring this, if you're doing it through your SCADA, you'll know at all times where your fuel levels are at, and then you can also set low fuel alarms. So you should never run into a situation where it's 5 in the morning and your site goes down because you ran out of fuel. The only reason why that would happen is because someone could have just been ignoring the low fuel alarms. So in a typical installation, it's usually after the winter months is when you go out and you'd replace your cartridges, and then it should last you through all the way through to that same time the following year. In situations where we've seen increased methanol consumption, it could be due to solar. So for example, if the way the system's designed is it's meant to be fully redundant. So if we run into a situation, let's say you're monitoring your system over the summer months and you notice that you're seeing some increased fuel consumption, and there's no forest fires in the area or really poor weather that would justify the EFOY running. We've had that situation with a client monitoring the system remotely, and by the time they got to site, they noticed that their solar panels were completely stolen. So the EFOY is designed for 100% reliability. So if something does happen to solar, it will carry the full burden of the load at site. The trade-off is just going to be a little bit of unexpected fuel consumption. One question that I get asked quite a bit is why are we using ultra pure methanol and why can't you use field grade methanol? And the reason for that is because we're just trying to maintain the integrity of the stack inside the fuel cell. If you use field grade methanol, you will foul up that stack and you will bring the unit to end of life. So the way that the cartridges are designed is we carry them in stock in Edmonton, Calgary, and Grand Prairie. And because you're monitoring your system remotely, you should know when you need to replace these cartridges. The other important thing to note about methanol is it's very high energy dense. So if you're familiar with a standalone solar system, again, you're looking at your autonomy and you're tying that back to batteries. Methanol fuel is capable of providing much more power than batteries are. So if I have a 70 watt continuous load and I'm using this 28 liter fuel cartridge here, that's going to provide 15 days of power. And then you've got 2 in a setup, so you've basically got a month of autonomy just tied to the fuel alone. If you try to look at what a month of autonomy is going to look like with regards to batteries, you're going to have a very large battery bank. So packaging options. Depending on the application, we've got a number of different ways that we can package the system specific to your application. The Pro Energy Box that you see over here, this is going to be for temporary installations. A lot of the users that are using the Pelican case style are usually using this for environmental monitoring, or it could be the RCMP for remote communications in the event of an emergency. Then the trailer platform that we have in the middle here, this is a mobile solution. So for the most part, that's going to be mining, communications, and security and surveillance are going to be the biggest users of that type of platform. But I do have some end users that are considering end using the trailer base for a number of different applications within oil and gas. One example being I have a client who's bringing in grid to all of their valve stations, but grid is going to take a little while. So they had one specific site where grid was going to be 3 months delayed. So they decided that they were going to mobilize the site using the EFOY fuel cell on a trailer base, connecting it into their UPS. So when that valve actuates and comes off the UPS, the fuel cell is just going to top that UPS back up. Once grid is at site, then they're going to take that trailer and then they're just going to move it elsewhere and repurpose it. The system you see on the right here, these are EFOY Pro cabinets. These are stationary systems, and these are going to be the most common installation that you'll see throughout the presentation. So for uses for the fuel cell, for the purpose of this presentation, I'm going to focus a lot on oil and gas applications. I'm going to walk you through a block valve application for here in Canada, and then for a client in the US. Pipeline risers, cathodic protection, SCADA and instrumentation, and then I will touch on a communication and security surveillance system as well. So jumping right into some of the reference case studies. So this is a pipeline up in northeastern BC. What's interesting about block valves is it's easy to think that you require a fairly large power solution just based on the power, the peak power that you're going to see during inrush when you're actuating the valve in the event of an emergency. When you actually look at the overall load profile for this type of application, it is fairly low. Those actuators are only going to actuate in the event of an emergency. So when I average the power requirements out, generally on these valve sites, we're seeing anywhere from 80 to 90 watts continuous. But we also have to factor in any other devices that might be running off of this system as well. So for us, typically we're going to see some form of communication. We'll have radios in the system, and then we're also going to see some form of control with regards to either a PLC or something like a SCADA pack RTU. So each client's very different. So the way that we've packaged these systems and designed it is very specific for kind of what you're looking for at site. So for this particular client, what they used to use at their valve sites was thermoelectric generators. And why they were interested in the EFOY is because they used to have an electrical shelter at these sites where they would put their batteries and their PLC. And what the EFOY allowed them to do was to completely eliminate that building and go into a suitable off-grid enclosure. That's the fuel cell that you see right here with the solar array. So there was significant cost savings for that client when they moved away from that building and went with the fuel cell. So that's a 110 watt unit over there. The other thing that's very unique about the fuel cell is when it's producing power, it's also producing a significant amount of heat. So we capture that heat in our cabinet and we keep our batteries nice and warm. For this client, they had a full PLC integrated into the side cabinet of the EFOY as well. So a PLC can't see temperatures below 0 degrees. So we took in some extra considerations just to maintain the temperature in that side cabinet. But for the most part, when the EFOY is running during the winter months, that's really when you're going to see it generating heat and keeping your batteries nice and warm. And then some of the other advantages that this offered to their client was the fact that they could remotely monitor the system. They knew at all times what was happening. They can check in on the status of the EFOY. They knew where their methanol consumption was at, and they knew whether solar was providing power or if they were just running off of the fuel cell. So having that remote monitoring, which also allows operators to remotely monitor and control the system themselves, was a huge advantage, especially in these very remote sites where some of these are helicopter access only. So we're really trying to cut back on windshield time and man hours. In a properly sized system, you really don't have to go out and visit this until once a year when those fuel cartridges need to be replaced. The other thing that was unique about this package for this specific client is they had a very strict ESG corporate policy where they were trying to eliminate methane and their carbon footprint wherever possible. And so the EFOY was a 99% reduction in emissions compared to what they were using previously on their valve sites. The next application is a pipeline riser. So riser sites are actually a great application for the fuel cell because traditionally there's not a lot going on at these sites. You're going to have some instrumentation, some form of communication and telemetry. So generally we see between 45 watts and 65 watts continuous as the load. So the package that you see over here for this particular client, they're going with a 110 watt unit. And what they like about the system is the fact that it's very low maintenance. So when they were weighing out options on what type of power supply they were evaluating when they were originally designing these sites, they were kind of forced to look at using the gas from the pipeline to generate power. And to do that, that meant that they were going to have to tap into that line and it was going to be quite expensive. So the benefit that the EFOY brought was just the fact that it is an independent fuel source. So there was no need to touch the pipeline. Really, we just needed to provide the power for all of that instrumentation. And then the added benefit that we were able to provide with this package is, it's kind of hard to see, but on the EFOY right here, you'll see a side cabinet. So we did a fully integrated RTU side panel for this client. So everything was certified and tested here in Calgary. And then when it hit site, it was a very simple install. So they saved quite a bit of money with regards to installation and then just the low overall total cost of ownership on a pipeline riser. I mean, the EFOY for this particular client, they're probably going to see less than $400 a year in fuel, which was some significant cost savings. So this is another pipeline valve control application as well. This one's in Midland, Texas. So this is just below the Sun Belt. So obviously in Texas, the concerns that they have are very different than what we're seeing up here in Canada with regards to temperature. So solar works great, but the hot heat can cause issues for batteries and the sizing of the solar array. So what we did here is we created a stationary high heat temperature rated enclosure. And as you can see, you've got the solar panels kind of on the back that provides some shading on the cabinet. It's also painted white. What you can't see is that there's a double wall inside the cabinet that allows for airflow as well. So when we're doing valve applications in Canada, I try to keep all the heat inside the cabinet during the winter months. And it's kind of the exact opposite when we're looking at applications like in Texas. So there's fans that are included in this system as well. So inside, when that internal temperature of that cabinet gets hot, these fans will automatically kick on, cool the cabinet down, and then they'll kick back off. So they are thermostatically controlled. So this is a cathodic protection application for a pipeline company. So traditionally what happens with cathodic protection is you're putting impressed current into your pipeline to prevent corrosion. So a lot of the time you're using a rectifier that's AC supplied. So that could be coming off of a compressor station, for example. For this client, their compressor was getting shut in, and so they needed to continue to protect the pipe, but their power supply was moving. So instead of looking at bringing in grid, this client went with the EFOY fuel cell. And what's kind of unique about this specific package is instead of supplying AC power to the ground bed, we've got a DC controller integrated into the side cabinet of the fuel cell that's automatically adjusting and changing to ground bed conditions and providing straight DC power. So when we looked at the total cost of ownership for this type of system compared to something like they were considering a thermoelectric generator as well, we saved them upwards of $60,000 over 5 years just by installing the EFOY because of the fact that there's really no maintenance required to it. It's designed to turn off and on to the end of life. And then again, they were going out once a year to swap out their fuel cartridges. And then they also didn't have to go out. If you're familiar with cathodic protection systems, sometimes you have to go out seasonally and adjust the current output based on your changing ground bed. But because the EFOY is automatically doing this, there's really no need to go out seasonally anymore. So we were able to save them quite a bit of man hours as well. This client was also debating something like a gen set. So if you do run into a situation where it is a shut-in and you've got a gen set that's supplying power and you want to try to move away from that, when you install something like an EFOY fuel cell, just because when you're looking at the carbon output, the fuel cell is one of the most eco-friendly ways of producing power. So depending on what you were using at that site previously, you do have the potential to generate carbon offset credits for this type of installation. And I've got one client right now where we're trying to work through this and figure out what that looks like. But for them, that might mean $12,000 a year for up to 8 years, just in carbon offset credits. So not only were they able to save money by installing this system, but now that systems could potentially become a revenue generation for them. So this is a multi-well pad application. So again, it really depends. We find that each end user kind of has their preference for the way that their site is designed. Generally speaking, when you go to up to 8 wells and below, the power requirements are typically very low. So for this one, it's a 90-watt continuous load. This is in the Rocky Mountain House area. And this client went with a 110-watt package. So what's unique about this setup is originally that client was using thermoelectric generators for power generation. And because a TEG is a combustion device, it falls under gas code. So they were designing their sites around the TEG and where it needed to be placed because they needed that 25 meters of spacing to be compliant with regulations for that province. Because the EFOY is not producing power through combustion process, we fall under electrical code. And so we were able to get significantly closer. So they installed our system 3 meters outside of that classified area, and they estimated that just in the spacing alone, that saved them about $10,000 in cabling and trenching. And then it just gave them more flexibility on how they wanted to design that site. They could kind of move the EFOY where they needed to versus designing everything around the power supply. For this customer as well, it was great because they were using tanked fuel to run their TEG. So operational cost savings were fairly significant. I believe they've seen an ROI in the first year of installing this system. And then they also were able to say that they reduced their emission footprint. So I've got 2 more minutes before I want to wrap this up and get to some questions. But the last system that I wanted to mention was the security and surveillance package. So this is for the Trans Mountain Pipeline, and what this system is providing power for is site surveillance, access control, and emergency e-mustering. So employees are badging in and out, and then this client has the ability to remotely log into these cameras and see exactly what's happening at all of their sites at all times. What's interesting about the EFOY side of things as well is that we were able to provide a package where they could roll our monitoring into their security monitoring platform as well. So they have full visibility on what the complete system's doing. And I believe that they're monitoring that through an app on their phone, and then there's a dashboard that they have on their laptops as well. So it was a lot of information. I went pretty fast through that. If anybody has specific questions or concerns about any of the packages that I briefly touched on, please don't hesitate to reach out to me. So this last slide here, just showing some of the advantages of the fuel cell. So really, I would say capital costs, we are comparable to what other low power offerings there are out in the market. But really where you see the benefits of the EFOY is going to come into the operational budget, just because it is so low maintenance. It's about $400 a year in fuel, depending on what size of package you have. So over a 10-year span, the EFOY does, depending on kind of what you were previously doing at site, we generally will save you some pretty significant money, especially with just the ability that it's doing everything automatically. So if you've got a system where maybe it's a solar system and then when it can't keep up, you're going out and you're rushing out a genset for emergency backup, the fuel cell is automatically turning itself off and on based on batteries and solar, so there's no need for user intervention in that package. The other advantage that we're offering with these types of systems is just the fact that we can integrate and supply a full turnkey setup and keep your footprint at site nice and small. So instead of having a battery bank sitting on the ground, an RTU panel and on one side of the site, we can kind of combine everything into one nice package so that you're minimizing how many piles you need to install at site and just really trying to aim to keep your footprint as small as possible. Like I had mentioned before, all of the systems are designed to be fully redundant as well, so they are highly reliable. And then if something does happen to solar, the EFOY will keep your site completely operational. The trade-off is just a little bit of unexpected fuel consumption. And like I had mentioned before, the way that you're producing power with this fuel cell, it is one of the most eco-friendly ways of producing power. So we've got a lot of clients that look at this solution just because with such emphasis on reducing our carbon footprint, this is a really nice way to bridge the gap between, I know in my experience, we've got a lot of engineers that want to look at doing standalone solar, but then as soon as that kind of hits operations, it's challenging because then you're looking at battery interval replacement, fairly unreliable, and it becomes a bit of an operational nightmare when you're looking at standalone solar. So the EFOY is nice because it bridges that gap. It gives you the green solution, but then it's also reliable. So then operations kind of is more comfortable with having the solar out in the field, knowing that the fuel cell is there for full backup when required. So if you go to our website, check out some of the different packages that we've got. We've also got some training sessions posted and more webinars. So please feel free to take a cruise on that. And here's my contact information as well. So now I'm going to get to some questions. All right. So why not just install a fuel cell without the solar panel? Does it provide significant OpEx saving versus running excessively off pure methanol? I'm not familiar with the cost of pure methanol. So great question. So yes, so the reason why that we integrate the systems with solar is just because we want to look at keeping the operational budget as low as possible. So if you look at the cost to install a couple solar panels and what that looks like compared to what you're going to pay in methanol fuel, there is a significant difference. So we always supply these systems with solar because it is meant to be like supplemental power to solar. The only time that we really provide the fuel cell as continuous power without solar panels is application specific, and it really just depends on what you're doing, and as long as it's a temporary installation. So from my knowledge, it's really just the RCMP that use the fuel cell for emergency communications without any solar panels. Are there any temperature limitations for operating in Arctic environments? So that's also a great question. So the fuel cell itself, I believe, is rated to -20. With our packaging, it's the cabinets are tested to -40 degrees. But then we also have some extreme cold weather kits because we do have systems operating in the Arctic, mountaintop applications. So we can take into consideration just some extra. Like we've got options depending on exactly where you're installing the system. But for the most part, when we're testing these systems, we also bring them down to -60 degrees in a temperature control situation as well, just because I know that for us up in Canada, we're starting to see our temperatures and our winters are starting to get more harsh. So we are trying to plan around that. Is the voltage a regulate output? Sorry, Sean, I'm not sure what you mean by that. Let me follow up with you. For the voltage for the EFOY, it's coming in 12 volts or 24 volts. On our 500 watt system, we do have a 48 voltage option as well, just because typically the users for the 500 watt unit are going to be more telecom. And that's the other thing I should mention as well. If you've got AC loads, we can supply an inverter as well. We just really try to stick to DC devices when we can, just to minimize any inefficiencies. Do you have any reliability data that you could share? Imran, I will connect with you after this and we can chat more about that. But yep, I have no problem sharing some information with you. Are there common failure points associated with the EFOY? It looks like the rest of your question kind of got cut off, so I'm going to follow up with you as well. But I would say the challenges that we've seen on the EFOY is really the rule is not to let it run out of fuel. So the fuel cell itself also has thermostats inside, and so it'll protect itself. So let's say that it's the dead of winter, it's really sunny out, so the fuel cell doesn't necessarily need to run because solar is able to keep the batteries at float, but the temperature inside that cabinet starts getting a little bit cold. The EFOY is going to automatically run an antifreeze, and it's always going to preserve its stack life. So the challenges that I've seen in the field related to failures is people ignoring low fuel alarms. And then because the EFOY can't run antifreeze mode unless it's connected to fuel. And then I would also say, just with regards to sizing as well, if we put a system out in the field sized for a specific load, and then I've seen situations where someone tries to tie another well in that the system wasn't originally designed for, we can run into some challenges with regards to increased methanol consumption just because the EFOY is being overloaded. So if you are planning to expand a site, or you want us to take into consideration some future power provisions just so you can scale that site, we'll just have a conversation with that up front so that we can plan and design that for that. Because the unique thing about the EFOY is it's load following. So it's only ever going to consume as much fuel as it needs to bring those batteries back up to float. So it's not the end of the world to oversize a system. If you're familiar with something like tags, if you oversize a tag system, it's always going to produce the same amount of power, and it's always going to consume the same amount of fuel, regardless of how much power you're actually consuming. So it's nice with the EFOY because it's throttling back and forth. Okay. What are the most often maintenance issues you have seen? It's like I had said before, it's really just letting the fuel cell run out of fuel. That's the most common issue, and it generally only happens once. If it's a client that's unfamiliar with the technology, or they didn't realize that they were ignoring the low fuel alarms. But the EFOY, there's no preventative maintenance required on the fuel cell. When you are going out to site once a year to swap out your fuel cartridges, I do recommend that you do a health check on your batteries as well, just because the fuel cell's not really smart enough to know if you've got a bad cell. So it's always going to try to bring a dead battery back up to float. So it's got a timer built into it. So let's say the timer's set for 12 hours. If we see that it's always timing out, it will indicate that it thinks something's wrong with the batteries. But for the most part, that's really the only maintenance issues that we experience. It might be helpful to mention that if the fuel cell is operating without solar for long periods, the fuel cell will have a significantly shorter life. Yes, absolutely. So when we're sizing these packages, we're also taking into consideration life expectancy on this system, because we want to try to, for the most part, when I'm talking to clients, I say around year 7 is when you want to budget for looking at how much power your fuel cell is producing compared to what your load is. And then when your fuel cell does come to end of life, it's not like you have to buy a completely new package. You can refurbish that fuel cell, or you can just swap it out for a new fuel cell as well. So our service team will always give you a repair cost. I would say it's pretty typical for that to be around $3,000 for the 110 watt EFOY. And then they'll quote you a price of a replacement as well. Can EFOY support lighting load? Yes, yeah, it can. We prefer to do LED lights where we can, because really what we're doing is we're just trying to find low power devices that complement the EFOY. So it really just depends on really what you're looking for. So Imran, we can follow up afterwards so I can get a better idea of what you're thinking for that lighting load. Is it easy to rebuild the wearable parts? So that needs to be done by a trained and warranted service technician. So Simark will do the refurbishing of the fuel cell. So if you run into a situation where your fuel cell does need to get refurbished and you yourself don't have a spare unit to keep that site operational while it's in for repair, we can get you a hot spare and then swap it out once we've repaired your fuel cell. So that looks like all of the questions for the most part. So again, it's 2:35. I've went over time. I apologize, but thank you for taking the time to tune into the webinar. I hope it was helpful and you guys learned something new. So again, you'll get my contact information. So if you've got any questions or concerns, please don't hesitate to reach out to me. Thank you.